So yeah, hi guys, let us start with the session 2. You guys remember we had just finished up our session 1. At the end of the session 1, I had told you that this chapter, your chapter linear equation in two variables, this chapter was something that you could have finished in your session in just one sitting. So you guys see we had just completed chapter 3, which was coordinate geometry in one sitting too. Then we had a practice session, right? That got lengthy. We had some lengthy sums or some more sums that it took 2 sessions to finish up that. Now we are going to do what? We are going to begin with our session 2 of this chapter. This is just one session for your practice based question and some questions that were left earlier, right? You guys remember those questions were left in a session 1. At the end, we had our exercise 4.4 left and some questions from 4.3, right? So we are going to do them along with some sums that are practice based. So we will be having all of those together in just one video. So remember, this is practice video, not the conceptual one. If you have any doubt in your concept video, you can just refer to our YouTube page and you can check out that video, or you can just register yourself on our website and you can check it there also. We have some recorded sessions also. So if you have any doubt regarding any chapter, if you feel this session is getting slower and you are on the next chapter, no worries, we have recorded sessions there also. So you can watch that one if you don't want to watch this one. But I want you guys, if you're watching this, just take out your pens and notebooks and try to attempt each and every question on your own. Since this chapter is quite easy, you should be able to figure this one out pretty quickly. So let's start with this video and let's just recall everything that we have learned up till now. That means I'm going to tell you everything that you had learned up till chapter 3, because those concepts will also be used in this chapter. And then I'm going to tell you something that we had learned in our chapter 4, right? So you guys remember both of these chapters are interlinked because in chapter 3 we understood the point of coordinates, right? We had understood coordinate geometry. Now when we came to our chapter 4, which was linear equations, this concept was already discussed in your chapter 2. So you guys remember each of these chapters quite linked with one another. So you guys see linear equation in two variables. It was what? It was just your algebraic expressions when being provided with an equality, or you can say when an algebraic expression was leading up to some answer that was actually not an expression, that was an equation. So linear equation was what? It was that which had a maximum degree of 1, right? You guys remember its maximum degree was 1, then that polynomial became your linear polynomial. But if we had equality to that polynomial, then it was what? That it was your linear equation. Now, linear equation in one variable means when you have just one dependency in your entire statement. But if you're dealing with two variables, that means nothing out of those two is exactly dependent on one another. Although something can be done, if there is any dependency, that means one value is dependent on the other, then you can either use your linear equation in two variables or you can use linear equation in one variable also to solve that exactly same sum. Let me just give you a quick example of this one. If I tell you my sister is 9 times as old as me. So you guys see, if I assume my age x, then my sister's age will be what? It will be 9x. Or we can do what? Or we can do it like this. If I assume my age to be x and my sister's age to be y, then according to question we do have what? We have this. My sister's age is 9 times of my age. That means if my age is x, then 9 times of that will be what? My sister's age. So I had assumed my sister was y years old. So her age was what? Y was equal to 9x. So you guys see, when you have dependencies in your statement, then you can use either linear equation in one variable or linear equation in two variables. That can happen at any given point if you have dependencies. But what if, let me just tell you, if we have something like this, let's say we are billing something and we have purchased, let's say, a bat and a ball. Now you guys see, I had purchased, let's say, one bat and 3 balls and my cost was, let's say, 1100 rupees. Now you guys see, there is no link between these two. Bat is different thing and ball is different thing. Together, if we use bat and ball, we can play cricket, right? We can do that. But I haven't told you what is the dependency between these two. Now in such scenarios where you don't have any dependency, then you have to use linear equation in two variables. That means you will be assuming one quantity as one variable and another quantity as another different variable. So remember, you guys should be remembering the concept of your variables, right? Variable is any alphabet or any quantity that is used to denote some unknown quantities. like we are going to do it now. See, I told you that let's say cost of one bet is X rupees, right? Assume this one. Let's say one bat is equal to rupees X. And let's say cost of one ball is rupees Y. And then cost of three balls will be what? It will be 3Y. And together, X plus 3Y, that is equal to 1100. So guys, see, this is what? This is a linear equation in two variables. Since we did not have any dependencies here, our bat was different, our balls were different, they were not linked together. But let's say if I had given you something like this, if I told you that the cost of one bat was same as cost of 5 balls, then you could have done it like this. You could have assumed cost of one ball to be X, then cost of 5 balls will be 5X. That is same as the cost of one bat, right? So one bat was equal to 5X and together you had 1100. So that means cost of one bat, that is 5X, cost of 5 balls, for this example, let's say they were 5X and together we had what? 1100, right? Let's say I had given you that I had purchased one bat and 5 balls, such that cost of one bat was same as 5 balls, then what an actual bill was 1100, then what was the cost of the bat and the ball? Then you can say this is your one bat, these are your 5 balls, together you are having what? 1100. Or you can do it like this. If cost of one bat is let's say Y and cost of one ball is let's say X, then 5X is the cost of 5 balls, that is same as Y. So you can say X plus Y equals to 1100, where Y is equal to 5X. So you can replace the value here and then you can get the answers. So if you have dependencies, it does not matter which type of linear equation are you choosing, whether in one variable or two variable. Just remember, if you have dependency, if you don't have any dependency, then you have to use linear equation in two variables or more than that if you're dealing with more conditions there. So this was whole concept right here. Now let's just move forward, and we had understood the concept of our solutions, right? You guys remember we had the concept of solutions. Then what were those solutions? You guys should be remembering that solutions were what? They were this. If you had a linear equation in one variable, like if you had something like this, 2x plus 1 that was equal to 9. So you guys see, at most you could get here was what? 2x equals to 8, x should be 4. So you guys see, you only got one value, right? Or you can say one solution. Now what actually is solution? So let me just write it here. We had one solution, that means the value of x, which was 4. Now what actually is a solution? The solution is that value of a variable. After substituting that value in your linear equation, both of your LHS and RHS must be equal, or the equation must be satisfied. Like in this case, I know my value of x is what? It is 4. So if I put it in our LHS, 2 into 4 plus 1. So you guys see, 8 plus 1, that will be 9, which is same as my RHS. So guys see, a solution is that value of any variable in an equation. After substituting that value, your LHS must be same as your RHS. So that was the concept that we had learned earlier, right? Now for one variable, you will be getting only one solution. Now let's move on and let's study the concept of two variables. Now what if we have linear equations in two variables? Then what would you be doing? So remember, this was the concept that I had told you earlier also. If you have more than one variable, then you need to have more than one equation. If I tell you specifically, then if you have two variables, then in order to get their answers, you need to have two equations. So as many variables as you have, as many equations you should have. Now in our first case, like you guys remember, in a linear equation, one variable, I just had only this, right? 2x plus 1, that was equal to 9. I got x, which was 4. You guys see, I only had to find out the value of x, and one equation was sufficient to find out this value. But what if we had something like this? 2x plus y equals to 9. Now you guys see, in this scenario, if I just look at this one, I just have one equation. I am dealing with two variables. In order to get their solutions, if I have just one equation and two variables or more than one variable, then solutions will be what? Then solutions will be infinite. And how will I be getting those solutions? I will be assuming one variable to be some value, and I'll be finding out the another one. So in this case, if I had to find out two solutions of this equation, we had done something like this. 2x plus y equals to 9. Firstly, we had assumed x equals to 0. So if we had taken x equals to 0, then y would have been 9. And if we had taken y equals to 1, then x would have been 4, right? So you guys see, if I had assumed a value to a variable. If y was 1, then x was 4. So guys, see, we used to generate this table, right? We had 1x and 1y. So when we had x0, y was 9. When we had y1, x was 4. So guys, see, if you are finding out solutions of linear equation in two variables, then you will be having the solution in pair, like your x and y. Then you can use what? You can plot these points on your graph, and you can plot them easily, and you can just draw a line. Either that line will be straight line, that line will be parallel, whatever that is, you can easily plot these. So next concept was plotting them on graph. So it was quite easy. If you had an equation which was like this, ax plus by plus c equals to 0, then you could have easily put those values on your graph, right? You could have plotted them very easily. You could have just taken their x and y's, then you could have just drawn the graph. This was your x-axis, that was your y-axis. Now you could have plotted them quite easily. If you had an x, so any x will be lying here, a y will be lying here. The intersection of both of those points, that will be your coordinate. So all these things were discussed earlier in our first session. And lastly, we had this one. If we had a coordinate where we had some values like this, if we had x comma 0, then you guys remember that point will be lying on our x-axis. If you had something like this, 0 comma y, then you guys remember that point was lying on our y-axis. And if we had something like this, x equals to a or y equals to a, then when it was x equals to a, line was parallel to y-axis. And when we had y equals to a, line was parallel to x-axis. And in such scenarios, when you had this type of things, then you guys must remember, if they had asked you solutions, if you had to plot x equals to a on number line, if you had to plot that on number line, then any value of x equals to a, that will be a finite point on number line. But what if they had asked you to plot that on graph? Now you guys see, if you had to plot x equals to 2 on graph, then it would be like this, 1, and let's say this is 2, right? So the line will be parallel to y-axis like this. This is x equals to 2. So if they had asked you how many solutions will there be in the graph, then you guys see, there can be as many solutions as you want. See, if I have this 1, this will be what? This point right here, this will be 2 comma 1. Then if this is 2, then this point right here will be what? 2 comma 2. Similarly 2 comma 3, 2 comma 4. So guys, remember, if you are dealing with something like this, either x equals to a or y equals to a, remember, if you have to plot them on number line, that point will be just 1. So remember, on number line, there will be only one solution. But if you are talking about your graph, then remember, on graph, there will not be just one solution, there will be infinite solution. How will that be? It is quite easy. See, I have x equals to a, right? Remember this? I had something like this, x plus 0y minus equals to a, right? Then you could have assumed any value of y, then you could have got the value of x. Since if you had plotted y equals to 1, then 1 into 0, it will be 0, and you will be having x, which will be what? It will be 9, right? So when y was 1, x was 9, then y was 2, x will still be 9, y is 3, x will still be 9. So you guys see, value of y is not fixed, but x will be fixed because we are having 0y. So any value multiplied with a 0 will be 0. So whether you have 0 into 1, it will still be 0. When you have 0 into 2, it will still be 0. So y will not be fixed, but on graph, x will be fixed. So your line will be like this, parallel to your y-axis, but the points will be infinite. You can have as many points as you want. So this is the thing that we had discussed in the last session. Now I'm going to pick up and start with the questions. So I hope you guys don't have any doubt in this. So let's start with the questions now. So these are some MCQ questions. I have around 12 or around 20 to 25 MCQ questions. Let's start with this one. The solution of the equation. Now you have to check which is the solution of the equation. Now you guys remember what was solution? Solution was that value or those values. After putting those values in your linear equation, if both your LHS and RHS gave you the same answer, then that will be the solution. Now you have to do what? You have to assume all of these values in this line. Then at any particular value, if your LHS is same as your RHS, then you can say that is the solution. So if I just erase this one, I can see if I put, now you guys remember our pairs are like this, x comma y, right? So this is x, this is y. So if I put it here, x equals to 0, y equals to 2. So I have what? 0 minus 2 into 2. So you guys see 0 minus 4, that will be minus 4. But our RHS is 4, that is not equal to 4, right? So this cannot happen. Now if I assume this one, you guys see 1 minus 2 into 1 equals to 4. So you guys see 1 minus 2 not equals to 4 because it will be minus 1 which is not equal to 4. Right, that is the point. So only value I can see here, that will be this one. See, 4 minus 2 into 0. So you see 4 minus 0, that will be 4. That is same as, that is same as our RHS, right? So it is equal to 4, same as our RHS. So our value will be this one, right? Now in graphical representation of y equals to minus, when you have to plot this, you guys remember when you had something like this, y equals to a, then what was the scenario here? A line parallel to x-axis, a line parallel to y-axis, passing through origin, or none of these. Now you guys remember I had specifically told you earlier also, if you have something like this, if you have y equals to a, line will be parallel to x-axis, right? So answer will be what? It will be parallel to x-axis. Now you can plot this one. See, this is your graph. This will be, let's say, y equals to minus 4. So this is x-axis, this is the y equals to minus 4. This is parallel. So answer will be what? It will be A. Now let's move forward and see the solution of this one. What will be the solution of this? So you guys see 2x plus 1 equals to x plus 3. If I solve this one, that will be what? X equals to 2. So solution is what? It is 2. You have to just solve this one. This is quite easy, right? Answer was 2. Now you have this equation, you have this one, the graph of x minus y equals to 0. Now one more thing, let's just firstly do this one. If x minus y is equal to 0, then x will be what? X will be same as your y, right? If I just write it here, you have x minus y equals to 0. This is minus y, on the other side that will be positive. So x is equal to y. So whatever you put here as the value of y, that will be same as your x. So your coordinates will be like this. Either you can write it like this, y comma y, which is your x right here, or you can write it like this. Both of the values will be same. You can write it like that, x comma x. So you guys see, if you try to solve this one, if you have something like this, x equals to y, so both of the values should be same. Now you guys see, if I put y3, I will be getting x3, which is not the point here because we are getting 2. Similarly, if I put y4, I should be getting an x4, which is not true here. Again, not true. Only answer that can happen here is this one. And one more thing, while you're dealing with anything like this, x equals to y or x equals to minus y, then remember, if x is equal to y, then your pairs will be having same values, a comma a. But if it is equal to negative of some other thing, then it will be like this, minus a comma a or a comma minus a. Depends on which value is negative. Now in our case, y is positive, but the x outcome will be negative y. That means it will be this one. If I had been something like this, y equals to negative x, then x would have been positive, but y would have been negative x. So you can say it could have been minus a comma minus a. So this is the whole thing that you guys should be remembering. So these are the things. Keep in mind, we are having some questions on this. So you guys see, we have this one. Now graph of this equation intersecting at x-axis. Now you guys remember, any point on x-axis, if you had any point on x-axis, its coordinates were like this, a comma 0. Now you have to look for that point where y is 0. I can see y0 here, I can see y0 here. Now we have to do what? Plot these, put these 2 points here. If that solution is verified, then we can say that is the value. So if I put x7 and y0, 7 plus 0, that will be 7, same as your RHS. So you guys see, our solution is this one. If you had put this one, so minus 7 plus 0, that would have been minus 7, but our RHS was a 7, which was not as same as that. So remember, the graph line of this equation will be intersecting x-axis at this point, a comma 0. Then you have to do what? Just put your y0. So if I put y0, x plus 0, that is 7. So x will be 7. So your coordinates are what? 7 comma 0. Or you can just take the help of your options here. You can put those values one by one, and wherever you have the equation satisfied, then that will be the solution. I hope you guys remember this and you don't have any doubt on this, right? Now let's move forward. Now you have to point this one on the line. So you guys see, you have to just put this value in either of these equations. If I put it here, x plus 2, sorry, not x. If I put it here, 4 plus 2 into 1, that will be what? 4 plus 2, that will be 6. Cannot happen here. Now in this one, already can happen, but see, there is negative 6, right? 4 plus 2, that will be 6, but we have a negative 6, which is not equal. Now in this case, you guys see, 4 plus 2 into 1 equals to 6, which is true. This will be the answer. If you wanted to verify this one, you had 16, but our answer was 6. So only C option will be correct. So up till now, we had the answers, which were these. In our first, we had this one. In our second, we had this one. Third, this one. Fourth, this one. Fifth, this one. And sixth, this one. Now let's move forward and see. So graph of x equals to 2, what will that be? A line parallel to y-axis, quite easy. Linear equation of this. Now you guys remember, if you are dealing with just one equation and that equation has more than one variable, then remember there will be infinite many solutions. So there cannot be unique solutions. This cannot happen. Two solutions cannot happen. No solution. Not the case. Infinite many solutions. Now the equation this has a unique solution if x and y are. Now you guys have to verify this one. This will happen when, see, 2x plus 5y equals to 7 will be having a unique solution if x and y are what? See, if they are natural number, if they are positive numbers, if they are real numbers, if they are rational numbers. So what can happen if they have unique solution? Now you guys remember, in such scenarios they have to be what? All of these three are the part of your real number, so obviously they have to be real number, right? Now let's move forward and see what do we have. If 2 comma 0 is a solution of linear equation, this one, then you have to find the value of k. Quite easy. Put the values. 2 into 2 plus 3 into 0 equals to k. So 2 into 2, 4. 4 plus 0 equals to k. K will be what? K will be 4. So your answer is what? It is 4. Now, any solution of the linear equation of this in two variables is in the form of. Now, you guys remember, you don't have any y. So it should be having what? You don't have any y, but you do have an x. So let's just solve this one. 2x plus 0y, that will be equal to minus 9. So if I assume y0, then x will be what? Minus 9 by 2. If I assume y1, then it will be what? Again minus 9 by 2. If I put y2, it will again be what? Minus 9 by 2. So you guys see, value of x will be fixed. Your x will be minus 9 by 2, but y is not fixed. It can be any value. So answer will be what? It will be minus 9 by 2 comma m. So it can have any y, but it will be having just one x because we don't have any y. So 0y, in this case you can have y1, you can have y2, you can have y3, you can have y any value, but answer of this part will be 0, and 2x plus 0 equals to minus 9. So 2x will be minus 9, x will be what? Minus 9 by 2. So y will not be having any fixed value, but x will surely be having just one value. So this is the point. Now you have to find out the coordinates of this one where line cuts y-axis. Now you guys remember, on y-axis your x is 0 and y is what? Y should be having any value. So just do what? Put your x 0. So 2 into 0 plus 3y equals to 6. So 3y equals to 6, y will be 2. The answer is what? 0, 2. Understood? Because you were just looking for the points which were on y-axis. Then on y-axis you have something like this. So you have to put x0, then you have to put the value of y. So this will be the point idea. I hope you guys remember this, right? Now quite easy. We have done just this kind of some earlier also. Now we have the next part. We have this one. The equation x equals to 7 in two variables. It will be like this. X plus 0y minus 7 equals to 0, or x plus 0y equals to 7. Now match this one wherever you're getting this. X plus 0y equals to 7. That will be the answer, right? Any point on x-axis is in the form of, quite easy, this one. For answers, you guys remember what were those? You can just mark them. Now let's move forward and see a second part. So any point on the y equals to x is in the form of, you guys remember, I've already told you, if y is equal to x, then the points will be like this, a comma a. So answer will be what? It will be this one. Now equation of x-axis is in the form of, now you have to remember equation of x-axis. So on x-axis you have what? You have something like this. If you are putting any value on x-axis, so it will be what? For y equals to 6 is a line. Now y equals to 6, that will be what? Parallel to x-axis at a distance of 9 units from the origin. Quite easy. Now x equals to 5, y equals to 2. You have to put this one and get the answers. You guys see, 5 plus 2 only satisfy here. Your answer will be C option, right? Now let's move forward and start with a theory based question. So we have this one. Find the value of k if x is 2 and y is 1. You have to find the value of k when x is 2 and y is 1. So you guys see, you just have to plot it here. 2x plus 3y equals to k. So 2 into 2 plus y into 1 equals to k. K will be what? Let's see. It will be this. Sorry, it will be 3 into 1 because we are putting the value of y, right? So 3 into 1 equals to k. So 2 into 2, that will be 4, and 3 into 1, that will be 3. Quite easy. So k will be what? K will be 7. The value of k is what? It is 7. I hope you guys understand this, right? Now let's see, what do we have the next part? Now we have to find the points where the graph of the equation, graph of this equation cuts the x-axis and the y-axis. Now guys, remember, for x-axis, what are the forms of coordinates? They can be like this: a comma 0. They won't be having any y, but they do be having some x, right? So if I put it here, 3x plus 4 into 0 equals to 12. So 3x plus 0 equals to 12. 3x equals to 12. X will be what? X will be 4. So our coordinates for x-axis, what are those? They are 4 comma 0. Now for y-axis, you guys remember, for y-axis it is what? 0 comma a, right? There isn't any x, but there does is a y. So if I just put it here, 3 into 0 plus 4y equals to 12. Now guys see, 4y equals to, this is 12. That looks like pi 2, which is not the case. Let me just erase this. Yeah, 12. So you guys see, 4y will be 12, y will be what? Y will be 3. So your coordinates for the y-axis, they are what? 0 comma 3. So you have the values. If I just write them here, so for x-axis 4 comma 0, for y-axis 0 comma 4, sorry, 0 comma 3, right? So these are the values. I hope you guys understand this, right? It was quite easy. Now let's move forward and see a third part. Yeah, this one. What point does the graph of the linear equation, this is the linear equation, meet the line which is parallel to x-axis at a distance of 2 units? Now guys, remember, they have given you an equation x plus y which is equal to 5. Now you have to, what you see, at what point does the graph of the line meet a graph of this meets a line which is parallel to y-axis at 2 units? Firstly, let's do what? Let's take the help of our graph right here. So you guys see, we do have a distance. See, a line is parallel to y-axis at a distance of 2 units from the origin in positive direction. So let's say 1 and 2. So the line is parallel like this, right? So the line is like this, which is x equals to 2. You guys remember, if line is parallel to your y-axis, then there is a value of x. Now you have to find out the point of that line. If I just pass that line somehow, let's say if that is not the case, that won't be horizontal. Somehow that line is passing through this one. Let's say it is like this. Let's say that is the case. So we have to write this point, coordinate of this point, at which the line of the equation x plus y, which is equal to 5, will be cutting the line of x equals to 2. So that is the point. Just do what? You guys remember, if you have something like this, if a line is parallel to y-axis, they can be infinite many points on that line. So you guys see, the value of x is fixed here, which is 2, but the value of y is not fixed. So let's say it can be any value, an a. So what I do, I just put this coordinate. If I put the value of x, which is 2, in this equation, I will be getting the value of y. That value along with the value of x, that will be making a point which will be intersecting this line. So see, what I'm trying to do is, I'm going to put x equals to 2. So it will be what? 2 plus y equals to 5. Y will be what? Y will be 3. So 2 comma 3 will be the point where the line of this equation and already this line of equation x equals to 2 will be intersecting each other, or you can say will be meeting each other. So you guys see, if I just plot these, let's just do this one. X plus y equals to 5. Let's say x is 0, y will be what? Y will be 5. If I do it like this, if I put y 0, then x will be what? X will be 5. Let's plot this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So firstly, x equals to 2, that will be this line, right? Then we have to plot y equals to 5 and x is 0. So 0 comma 5 and a 5 comma 0. So 5 comma 0 will be right here. 0 comma 5 will be right here. So if I join them, so this is the line which is actually intersecting our point, right? So you guys see, if I had just drawn this accurately, so it is going closely to what? It is closely to 3 and it is at x equals to 2. So you guys see, our value will be what? If I just put this value, that means if I put x equals to 2 in this, I will be getting a y, which will be what? It will be 3, and point will be what? 2 comma 3. That will be the point at which equation of this line and equation of this one will be line of this equation and line of this equation will be meeting each other, or you can say intersecting each other. So this point right here will be what? It will be 2 comma 3. So I hope you guys understand this and you don't have any doubt in this, right? Now this is very important question. Remember, this is very important. Similarly, your fourth question is also very important. Determine the point on the graph of the equation, which is this one, whose x coordinate is 5 by 2 times its coordinate. That means its x is equal to 5 by 2 y. So our coordinates are like this, 5 by 2 y comma y. So we have to find out the point, right? Just put this value and this value in this equation. So you guys see, if I put x equals to 5 by 2 y, then we have what? 2 into 5 by 2 y plus y is already y, so plus 5y equals to 20. So you guys see, this will be what? A 5y plus 5y equals to 20. 10y equals to 20. Y will be what? Y will be 2. If I replace it here, then I will be having what? 5 by 2 into y, which is 2. So x is what? X is 5. The coordinates are what? 5 comma 2. And you guys see, if I just multiply this 2 with a 5 by 2, I will be getting the x, which is what we have here. So remember, we have been given that x coordinate is 5 by 2 times of its ordinate. That means abscissa is 5 by 2 ordinate. If our ordinate is y, then abscissa will be what? 5 by 2y. Then you have to do what? Just put the values of abscissa and ordinate in your equation. Just use that equality because that point is already lying on that line of the equation. So if you replace those values, the equation will be satisfied. So with the help of that, I will be finding out the value of x. Then I will be replacing that value and getting the value of, I will be getting the value of y right here. Replacing the value, I will be getting x. So this is what we have to do. I hope you guys understand this, right? Now let's see, what do we have next? We have this. Draw the graph of the equation represent a straight line which is parallel to x-axis 4 units above it. So we have to draw an equation of a straight line which is parallel to x-axis. Now you guys remember, line is a parallel to x-axis. So it must be having y equals to a kind of equation, right? Now I've been given that the distance is what? It is 4 units. So 1, 2, 3 and 4. So this will be the line right here, which is 4 units above origin and is parallel to x-axis. Let me just draw it neatly. So this will be the line right here, which will be y equals to 4. So this is the line that is parallel to x-axis. Now draw the graphs of linear equation, this one and that one. This is quite easy. You have to plot those. Now guys, see, when y is equal to x, whatever value you put here, your value will be same, right? So if I put x1, then y will be 1. If I put x2, y will be 2. If I put x3, y will be 3. If I put x0, y will be 0. Similarly, you have this one, y equals to minus x. Now in just this case, if you put x0, then y will be 0. But for any value of x, if you put x1, y will be negative 1. x2, y will be negative 2. x3, y will be negative 3. So you guys see, at any positive value of x, your y will be negative. So if you want to plot them, see, y, negative y, x, negative x. 1, 2, 3, 4, 5, and let's say those are the values. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now you guys see, x0, y0, that will be this point, right? x1, y1, that will be this point. x2, y2, that will be this. x3, y3, that will be this. x4, y4, that will be this, and so on. So you guys see, our line is straight, which is like this. This is the slope, right? It is a straight line, but a slope. Now on the opposite case, x equals to 0, same point. x1, y minus 1, that will be this. Then that will be this. This will be that, and so on. So you guys see, if y was equal to x, then there was a straight line in first quadrant. If y was equal to minus x, then there was a straight line which was in fourth quadrant. So these are the things that we have observed. So you guys see, the line is intersecting at origin. You can say the lines of both of the equations are passing through origin, right? So if you had started taking the value of x to be negative, then your equation would have been gone like this, and here it would have gone like this. So you guys see, if you had taken negative x, then y equals to negative x would have been here. And if you had taken something like this, if you had x negative, then y would have been positive for this point. So I hope you guys remember and you don't have any doubt in this. So this is the equation. Let's see, what do we have next? Determine the point on graph of linear equation, which is this one, whose ordinate is dash is abscissa. Now this is the same case. Y is 1:1 by 2 x. So y is equal to 3 by 2x. Now replace it here. 2x plus 5 into 3 by 2 x, which is equal to 19. You can solve this one and easily get the answer. So I will be leaving this to you. Now for the eighth one, draw the graph of the equation represented by a straight line which is parallel to x-axis at a distance of 3 units below it. Quite easy. Line parallel to x-axis, that means there should be something like this, y equals to a. Now it is 3 units below, that means a -1, a -2 and a -3. So this will be the line which will be parallel to x-axis, and this is what y equals to -3. Quite easy, you can easily solve these, right? These are quite easy sums. Now let's see what do we have next. It is this one. Draw the graph of the line of a linear equation whose solutions are represented by a point having the sum of its coordinates 10. That means x plus y is what? It is 10. Now I have to draw the draw the graph of this. Just assume y0, then x will be what? So if you have something like this, let's just make a table. So if I have x0, y will be 10. If I have y0, then x will be 10. So let's got them. 2, 4, 6, 8 and 10. 2, 4, 6, 8 and 10. So guys, see, this will be 10, 0 and that will be 0, 10. Just join them. So this is what? This is an equation for linear equation. Sorry, this is the line for the linear equation in two variables. The sum of its coordinates is what? It is 10. So that is the value. Now you have the next one. Write a linear equation such that each point on the graph has an ordinate 3 times its abscissa. So its ordinate is y, which is equal to 3 times its abscissa. So this is the linear equation, or you can write it like this: y minus 3x equals to 0. So quite easy sums, right? So these are the linear equations of the ordinate, which is 3 times of its abscissa. You could have done it like this also: 2y equals to 6x. That could have also happened here. Let's move forward and see. If the points these lie on this graph, then find the value of a. Quite easy. Put the value of x to be 3 and y equals to 4. So 3 into 4 equals to a into 3 plus 7. So guys, see, 12 equals to 3a plus 7. A will be what? 5 by 3. Because 12 minus 7 is 5 divided by 3. So it will be 5 by 3. Now you have the last question, I guess. How many solutions? 2x plus 1, x minus 3 are on the number line and in Cartesian plane. Now if you solve this one, you have what? 2x plus 1. If I just erase this, so 2x plus 1 equals to x minus 3. So x equals to what? A minus 4, right? 2x minus x, minus 3 minus 1, minus 4. So on number line, minus 4 is fixed, minus 1, minus 2, minus 3 and minus 4. So it will be just one solution. But what if on the graph? So if I plot it on the graph, so minus 1, minus 2, minus 3 and minus 4, right? So it will be a line parallel to y-axis and there can be infinite many points. So it will be what? On number line, one solution, and on Cartesian plane, it will be infinite many solutions. So I hope you guys understand this. Now let's see, what do we have? So we have some more sums. So we have to find the solution of the linear equation represented on x-axis and y-axis. Quite easy. For x-axis, you have x comma 0. Just put y0 and get the value of x. So if I put y0, x will be 8. Now on y-axis, I have to put x0. So if I put x0, then y will be what? Y will be 4. So coordinates are what? 8 comma 0 and 0 comma 4. Now we have the next one. For what value of c? This is important. The equation which is this has equal values of x and y. Now we have to find that value of c. Now you have been given that x is same as y. So if I replace it here, 2x plus cy, equals to 8. I know x is same as y. So 2x plus cx equals to 8. X common, 2 plus c. We have to find the value of c, right? So if I erase this, so that will be what? Let's see. If I take x common, or let's just do what? Erase this and let's find the value of x. So cx will be equal to what? It will be equal to 8 minus 2x. Then c will be what? 8 minus 2x over x. So that will be the value of c at which your x will be same as your y. So I hope you guys understand this. So this is the value of c. I hope you don't have any doubt with this. You just have to find the value of c, right? Just push everything else on the other side. So firstly pushed 2x, then push this y, push this x. So you will be getting the value of c, that will be 8 minus 2x by x. Quite easy. Now let's see, what do we have next? So these are the questions that were left from exercise 4.3. Now let's just quickly do them. Yamini and Fatima, two students of class 9 of a school, together contributed 100 rupees towards Prime Minister's Relief Fund. Write the linear equation of which satisfies the data. Now you guys see, I haven't you haven't sorry, we haven't been given, actually you and I, we haven't been given any relation between Yamini and Fatima. So you guys remember in the beginning of this video I had told you that if there is some dependency, then you can either use a linear equation in one variable or two, but here we don't have any dependency, we just know both of them have contributed 100 rupees. So if I assume Yamini has contributed x rupees and Fatima had contributed y rupees, then x plus y was what? It was 100. So that is the linear equation. Now you have to draw the graph. This is quite easy. Assume x0. If you put x0, y will be 100. If you put y0, then x will be 100. The coordinates are what? 0, 100 and 100, 0. Take a scale of 10 and then just plot this one. Quite easy. Now let's see what do we have next. This is our last exercise, I guess, exercise 4.4. So you have to represent this as linear equation in one variable. So it will be what? We have y equals to 3. So in one variable, it will be what? Y minus 3 equals to 0. In two variables, it will be what? 0x plus y minus 3 equals to 0. Right? Now we have to write this one in one variable. So this will be what? 2x equals to minus 9. X will be what? Minus 9 by 2. Now, in this case, it will be what? 2x plus 0y equals to minus 9. So these are the two answers of this equation. I hope you have understood each and everything. So by now, I hope you guys have understood each and every concept and you don't have any doubt in any part. So what we have learned in this chapter together, we had learned equation forms and a linear equation which was like this, ax plus by plus c, where abc and abe and c were what? Your real numbers, right? They could have had any values. Now in such case, if you had ax and by, just remember a and b could not be 0, but c could have been 0, right? If they had something like this, if they were 0, then if a was 0, then x will be what? Something divided by 0. That will not be the point here. Now linear equation in two variables, you guys remember we were dealing with only one equation, so it will be having infinite many solutions because we can assume as many values as we want and we can find out the remaining values. So graph of linear equation in two variables, straight line, already you guys know this. If x is 0, then equation of y will be what? Y will be 0. That is the equation of x-axis. So equation of y-axis was what? It was x equals to 0. Then we will be getting a value which will be on y-axis, right? And we had y equals to 0. Then we will be getting a value which will be on x-axis, right? X equals to a, straight line parallel to y-axis. Already know this. Y equals to a, straight line parallel to x-axis. So I hope you guys remember each and every concept from this chapter. Remember this chapter is quite easy. So I will be seeing you in the next video where we will be starting a chapter 6. We will most probably be starting a chapter 6 from tomorrow. So remember, we will be having that one, your lines and angles. This is quite interesting chapter. So we will be beginning that. So I will be seeing you in next video. Till then, practice as much as you can. And thank you for joining with this video. See you tomorrow.